What happening, guys? This is Mishu and welcome back to another brand new tutorial. So in this tutorial, we are going to compare between two transfer learning model. So let's get started and see the demo first. So as you can see here, these are demo applications we built before. So I'm going to click here to select one photo. So this is nothing but the photo for hand. And you can see here 98% accurate that B16 classification report it is hand. And MOBILENET classification 95% accurate that this is hand. So we can compare between the two models that which model is actually work fine here. So I'm going to select this one nothing but tennis ball, submit. And now you can see here it's 95% accurate that this is tennis ball. That's been B16 predictions. And this one is MOBILENET classifications, and it will say that 96% accurate that this is tennis ball. We can also select this one traffic light, submit here, and you can see here 100% accurate that this is traffic light, and also 100% accurate that this is traffic light. You can also click here to edit. This is actually built by Gradeo library, and Gradeo library actually help us to build this kind of application in machine learning based production levels. So save, and you can see here submit, and you can also see here 100% accurate that this is traffic light. Okay, so let's select this one photo and submit here, and this was nothing but cop 80% and the 70% accuracy. So this is the comparison between two models. So now let's get started and jump on the code. But before jumping on the code, you need to check this transfer learning playlist from my YouTube channel. So the first video is nothing but what is transfer learning and how can you use the transfer learning for image classifications. And the second video is nothing but for building the web applications using Python Gradeo library. So link will be in the description. You can also save this playlist on your YouTube. So let's get started and jump on the code. So this is the existing code we did before in part number 2. So if you miss this out, so please check it out. Link will be in the description. And in this part, we actually discuss about all the things for the building the web application. So how can I actually use the Gradeo library to build this, and it's easy to build that. Okay, so I'm going to actually revise the things one more again. So first we actually import the Tensorflow library from the import Tensorflow STF, and we load the model from the Keras application. And you can see I set the model to BZ16, and you can see here I create one functions here. This one the function for predicting the images, and also you can see here from field we are importing the images from NumPy input NumPy HNP, and from keras.application.bz16 we input the preprocessed input. So this preprocessed input is actually preprocesses the images based on the BZ16 model. And you can see here we actually get one request that's been response from this link. So this link is nothing but for the human readable level. I'm going to copy the code, this link, and paste it on here. So let's paste it on here and see the output. Okay, so make sure that you are connected on the internet. Okay, so I think I need to paste it out here again. Okay, so now you can see here this is nothing but readable levels. Okay, based on the 1000 unique classes. So you can also use that and get the text from this link. Okay, so let's go here and go on the full screen mode. Okay, so now you can see response equal to request.get, and you get the response, and based on the response you're actually splitting the text. Then you can see here use the PLU library for converting the image into a NumPy array based on the 3 channels RGB, and resize the images by 224 cross 224. It's up to it's actually based on our model. So if I go up and see this this model actually take the 224 cross 224 cross 3. Okay, so it actually take these images, so that's why you need to resize the images. Then you actually expand the dimension based on our CNN model. So this is nothing but the reshaping type and cross 224 cross 224 cross 3. So n is nothing but the number of images, that how many images you actually go to pass on here. Okay, and you can see a model.predict based on the images and flatten. That's when you actually convert this image into one kind of linear vector. Then you create one kind of dictionary types of on the labels and the floating point predictions. That's mean accuracy. That's mean we have 1000 classes. So for that we actually iterate through all the classes from here. Then we actually import the Gradeo library and also create one imports for images and reshaping the images. Not reshaping, you're actually resizing the images 224 cross 224 cross. It actually automatically do the Gradeo library. And you can see here we create one variable for data to actually catch the output. Okay, And you can see I actually put here sample images. It's on the same directory, cat1 hand doc testbook, all the things. Then we actually getting here gr.interface and function equal to predict images, and inputs equal to image and output equal to data. This output is coming from data, and capture sessions mean you are able to capture the snapshot from here. If I go down, you can see here screenshot options. If I click here, it actually take the screenshot from here. So I make it as true. That's mean I am able to actually take the screenshot from here. Examples equals nothing but the sample images. So it's the same as how you actually compare them. So but we need to just load the second model, MOBILENET V2, and we need to create two functions for that, for the two models. Then we need to actually create one list to actually on the instead of using the predict images. So let's have a look this one actually built before. So this is the code we compare transfer learning models, and I built it before because I'm not going to actually wasting the time. Okay, so it's easy. So just to import the Gradient library and import TensorFlow STF, same as this. We actually discuss about this thing. How can I actually do that? Then you can see here I actually initialize two model. First is nothing but BZ16 model, and another one is nothing but MOBILENET V2. You can also choose BZ19, ResNet 15, Inception V2, what kind of things you are actually making that. Okay, you can choose it after you. Okay, and you can see I initialize the two model, BZ16 model and the MOBILENET V2. Then we actually create two functions based on we actually discussed this thing on the web apps, the part number 2. And before you discuss that, so this is BZ16 classification. It also take one images and convert the image into number array. They resize the images, expand the dimensions, that means reshaping the images. Then pre-process the input based on the BZ16 model. Then again predict the images on the flat end. Then actually iterate to all the levels from here. So you have 1000 unique classes. Then we create one function for MOBILENET classification also. It's also same, no changes here. Just change is only this one, MOBILENET, and this was BZ model. Simple, this one. Then we import the Gradient library, and I think I import the Gradient library before, but I'm going to also import the Gradient library as here. And we actually shape design the images 224 cross 3 and data equal to gr.outputs and the labels number of top 5 classes. So how you actually run the code, and we see top 5 classes here, and sample images is nothing but cat1 title, so cat1.jpg, hand.jpg, and the dog.jpg. And also all the images is actually based on our working directory. And you can see here I create one list for all of the functions we written here. Okay, this one and this one, and BZ16 classification, the MOBILENET classifications, and the inputs and the outputs and the capture session. So you can also add some titles here. It's up to you. And you can see no titles is here. I'm going to actually interrupt the code. Code interpret. You can also add here the titles here. Okay, so let's actually put here the titles, one kind of titles that you can actually make this out. So let's the title be compare. Okay, transfer learning model. So you need to put here one comma here, and then you need to run that code again. Shift enter. And it takes few seconds to actually run the code. And now you can see one title is appear here. How you actually run the code, because we set the title here, compare between two transfer learning model. And model is nothing but BZ60 and the MOBILENET V2. You can choose any kind of them. So now you can see our code is run correctly, and click here to actually load the model. So now you can see compare between two transfer learning model. So you can also drag and drop the images from a directory. Just click on here. So I'm not actually drag and drop the images from here because we have all the simple images. So you can choose these ones. Maybe you can see a traffic light, and this one submit here, and you can also compare between two transfer learning model. So now your job is to be compare between the BZ19 and ResNet 15. See the difference between them, that BZ16 is good or BZ19 are good, or the MOBILENET classification is good. So which kind of you can also compare between 2, 3, 4, 5, any kind of, just you need to change on the functions. You need to create 5 functions, and on the list you need to actually mention the 5 functions here. I actually choosing the 2 1. You can also choose between, you can say between 2. You can choose 5, 6, 7, 8, any kind of model actually on the Keras. You can choose that. So this is the video. Hope you'll enjoy this video, and make sure to subscribe my channel, and don't forget to hit the bell icon for never missing an update. And I'll be back with another awesome tutorial. Thank you, and till then, take care. Bye bye.